This is the peer teach problem B. As you coach your classmate through this problem, it's very important. Your job is to create dialogue, not simply dictate the answer. You want to ask more questions than give answers. You want to coach your classmate to use their fingers to trace the diagram, draw the diagram, label the diagram, shade, sweep angles, to interact physically with the diagram. Here we go. I'm going to coach you through this problem, and your job is to coach your classmate. Step number 1. You are asked to find the midpoint of KM. Now, some of you are tempted to just bunny hop it, and yes, bunny hopping is right there, but if you're going to prove something mathematically, that requires mathematical computations. That's very important. Why do you have to do things mathematically? In computer programming, you can't just bunny hop points around. You have to computer program it using algorithms, and those algorithms involve equations. Therefore, even though you can eyeball the midpoint here, you're still going to do it using equations. So first off, here is your midpoint KM. So K, let's get our points here, is at 0, 0. M is at 4, 0. And L, which we will eventually need, is 2, 4. So add the x's, divide by 2. Add the y's, divide by 2. We are going to add the x's. That's 0 and 4. And add the y's. Notice I'm physically touching everything. That's going to be 4 over 2, of course, and 0 over 2. So your midpoint is going to be 2, 0, which is exactly what we expected. But now we have proven it mathematically. So that is a midpoint. We're going to draw in, because it's a midpoint, we're going to draw in the median. LQ. LQ now qualifies as a median. Why does it qualify as a median? Because we just proved that that is a midpoint. Median connects vertex to midpoint. Now, we're also going to prove that it's an altitude. So you're going to have to quiz your person if they remember what is an altitude. An altitude connects vertex to a right angle. So once again, you can't just look at it and say, well, it looks like a right angle, therefore it is a right angle. You have to prove mathematically that LQ and KM create a right angle. That's going to be the perpendicular, and which is the slope equation. So right here, we're going to find the slope of KM, slope, and we're going to find the slope of LQ, slope. There's your templates. So first off, Km, y minus y, that's going to be 0 minus 0, x minus x, of course, 0 minus 4. 0 over negative 4 is just 0. And this one, y minus y, so that's going to be 4 minus 0, and then over 2 minus 2, which gives us 4 over 0, which is undefined. Get your classmate to do this, please. Get their arms up, and remember, define one arm 0 horizontal, the other arm undefined vertical. Yes, that creates a right angle, even though it's not slope times slope is -1. Perpendicular lines are normally slope times slope equals -1. This is the only exception. Zero slope and undefined are automatically at a right angle. They're perpendicular. Why? Because zero slope is horizontal, vertical slope is undefined. Congratulations, you just proved that it's also an altitude. So your write-up, you want to coach the person through, is first you define a median. So number one, a median connects vertex to the midpoint, and Q is shown to be the midpoint of KM, so LQ must be a median. Number two, the slope of KM is 0, which is horizontal, and LQ is, there's an equal sign there, undefined, which is vertical. So KM and LQ are perpendicular, making a right angle. Therefore, LQ is also an altitude. Math meaning punchline.